Welcome. My name is Matthew Goronsky. Basically, what we do is we're a small startup and we manufacture the next generation of power plants. Basically, 5 billion tons of coal, 31 billion barrels of oil, 5 trillion cubic meters of natural gas, 65,000 tons of uranium are used to power the world. Solar and wind have proven unreliable, and the one answer to the world's energy needs is the thorium molten salt reactor. So, using the data from Idaho Power, a local company, power plant, they currently spend about 4.65 cents per kilowatt for their costs. Basically, the biggest cost drivers for any kind of power plant are the fuel. One of the major advantages of a molten salt reactor based in thorium is our fuel costs are basically about $32,000 a year for basically a 20 megawatt plant. That would be about 10% of Teton County's power supply. Thorium, by its nature, is a byproduct of rare earth mining. Basically, 3 rare earth mines could supply the world with all the power needs that they need. So what is a molten salt reactor based in thorium? Well, it comes from the government. Back in the 70s, it was basically being developed by Oak Ridge National Labs. The government shelved the technology in favor of what's called a plutonium fast breeder reactor. We had one built in America that turned out to be a dismal failure. It doesn't even run plutonium anymore, it runs uranium-235. The reactor itself is based on a liquid salt of lithium fluoride and beryllium difluoride. We convert 100% of the thorium to uranium-233, and of that uranium-233, we burn 100% of it. We do not work like a normal plant that burns only about 0.5% of the uranium. We generate no waste products because we are a salt. We keep the waste products in the salt until we can burn them as more power. One of the things about a salt reactor, we do not require a pressure dome because we're not based in steam. And we also do not require large storage tanks for the storage of the spent fuel rods or the long-term casts. One of the other major advantages of a thorium-based plant is we can't be used in the bomb making. Thorium, uranium-233 puts out a byproduct called uranium-232 that basically will kill anybody, destroy your electronics, and basically is detectable from about 50 miles away with a high-range gamma detector. So go ahead and try. Basically, there's multiple uses, the benefits of this. One is, since we're not based in a steam-based system, we're based in a molten salt, we can use the reactor for other products. One of them being, if you're in California by the sea, you can turn the seawater into basically drinking water with the excess energy that's in the plant. Thorium is abundant and will never run out. As I said, we have no pressure domes or storage tanks. It's not usable in a bomb. It's a been proven technology developed by Oak Ridge National Labs and shelved in the 70s. One of our major benefits is we have a very low fuel cost, can't be used in a bomb. We don't use like water in the sense of a nuclear plant, so we use a very limited natural resource footprint. Our plants are very, very small. You could probably put a 20 megawatt plant in a building about twice the size of this. Our markets are basically divided into 4 parts. Large nuclear complexes that are currently going offline, such as the one in California that just dropped offline for the 1,000 megawatt system. Medium reactor sites. The small cities, since our plants are so small and very safe environment, you can basically build a nuclear plant right in the middle of town and no one would ever know you have it there. And the other advantage of this technology is we can go in and build a disaster site reactor, which will allow bringing power quickly to a disaster site. The company is basically going to build the first prototype in Madagascar in a town called Tesmazio. We've got the contract in place. We expect to have the plant operational in 2 to 3 years and then sold off for $30 million. We will basically then either continue building off-site in the unregulated environments or building a 20 megawatt plant as our first one in Lincoln County, Wyoming. We expect NRC certification in 7 to 10 years, and then we'll be able to build anywhere in the country. We basically plan to build two styles of plants initially, 20 megawatt and a 250 megawatt. Because our plants are scalable and multiple, if you were to replace a plant like the one in Green Mill that they're putting in, you put in 4 250s instead of one big nuclear reactor. One of the major advantages of that is the reactor itself can be taken offline, do its maintenance, and your other 3 reactors are still producing power. You can even bring them up a little to keep your power level output at the same. Currently, there are 6 people on the group that's manning this. Myself, I've basically got a project finance background. I've basically worked on molten steel plants, jet engine test cells, and now this. Our designer, JT Stevens, he's basically ran the West Coast nuclear program for the Navy. He's basically worked in design, manufacture, operations, and maintenance of basically every Navy nuclear reactor since the Nautilus. Our salesman is named Joe Anderson. He's basically been in the power plant building industry for 20 years. He built the largest wind scale plant in the country, financed it and got it operational. Our financier is named Brenda Richen. She's basically got a lot of finance experience in small companies through large companies. She has been a consultant for about the last 15 years. Our lawyer is named Joe Black. He's the one that's handling the private placement memorandum. And our venture capitalist is named Randall Young. He's basically handling the financing end of it. Basically, we plan to raise $31 million. $5 million of that is for planning the reactor and getting the prototypes up. Our generator will cost about $8 million. The plant itself, building, will cost about $3 million. The reactor 10, and we have a $5 million contingency in the plan. Our timeline is basically, once we get the first round financing done, to have the plans for the reactor built in about 7 to 8 months. Our first uncertified reactor up and running in 2 to 3 years, of which we will then get a payment of $30 million from the company we're dealing with. We will then basically go through the certification design and or building more reactors out in Africa, where Obama's just guaranteed $9 billion for powering Africa.